All right, warm up time. Here we go. We have our packet, page 13, number 12, page 18, number 5. So for this one, it's the directions say solve by substitution with these two systems of equations. And then for this, on this page, for this question, it's solve by elimination so that we can get to our answer. We're looking for a coordinate point where these two lines intersect. If they, if I have two lines that intersect, you have one solution. If I have two lines that are parallel, you have no solution. And if I have a line that's exactly the same as the other one, you have infinitely many solutions. So this is one solution, this is no solution, and this is infinitely many solutions. Just so we know what that looks like. Starting at this first question, I want to solve by substitution. So I'm looking at whichever equation. If I solve for x or y, which one's going to be the easiest thing for me to do? So I look at this bottom equation, and I see if I move the 3y over here, the x is by itself. If I try to solve for y, I move the x over as a negative, then divide the whole thing by 3, and that gives me fractions. When I want to deal with fractions, I want to try to keep it as easy as possible. So I'm going to end up subtracting 3y on this side, and that leaves me with x is equal to negative 3y minus 9. So I'm going to take this equation right here, and I'm going to plug it in right here. Okay? So when I do that, I have negative 2 over 3 times negative 3y minus 9 minus 7y is equal to 6. So here we're solving for y. So that means that I'm going to get this answer before I get my x answer. So I'm going to use distributive property. Knowing my rules of fractions, if the denominator and the numerator are the same, they cancel. So that's going to leave me with a positive 2y. And then right here, this 9 and 3 is going to reduce. That's going to change to 3 times negative 2 is going to be positive 6 minus 7y is equal to 6. I'm going to combine like terms, which gives me negative 5y plus 6 equals 6. I'm going to subtract 6 on both sides. Cancels there. And I have negative 5y is equal to 0. Divide by negative 5. 0's on top, 0 always wins. So I've got y is equal to 0. Now I've got to find the x value. I can plug it back into one of the original equations, or since I've already solved here and x is by itself, I'm going to plug it in right here. So I've got negative 3 times 0 minus 9. Well, 3 times 0 is 0. That goes away. Negative 9 is my x value. Please make sure that you put it in the right spot. Since I solved for y, it goes here, and then I have to solve for x last, so you put it into the right answer. This would be your coordinate point answer. You can check it by plugging this into your calculator exactly the way it's written. Menu 6-4, go to the left side and the right side of the intersection. You'll see where that answer occurs. The next question is solving by elimination. Some of them where you want to have the equations in standard form, so x, y, and then answer. And then you want to line it up so that you are able to try to get rid of a variable. So if I wanted to get rid of x's here, I'd have to have my x's be either an 18 up here or a negative 18 down here, a 12 up here, a negative 12 down here. You really don't mess with the numbers. So I think that getting rid of y's would be a better strategy because 3 and 4 gives me 12, and I'd rather deal with 12 than 18. So that means I'm going to multiply this equation right here by a 3 to get that 4 to become a 12. And then this equation I'm going to multiply by 4. These both are going to be positive because the signs are already opposites of each other. So then I'm going to use distributive property. I get 27x plus 12y is equal to, that is negative 216. And then here we have 8x minus 12y is equal to negative 64. So then when I add a line and combine, I see that the 12y's cancel. It's called elimination. We're trying to eliminate a variable. And that gives me 35x is equal to negative 0, 6, 7, 8, negative 280. And then I divide that by 35. and I get x is equal to negative 8. So we have negative 8 for x. Make sure that we put it in the right location. And then we need to plug it back into one of our original equations. So I'm going to choose the bottom equation because my numbers are smaller. And then we have this, 2 times negative 8 minus 3 times y is equal to negative 16. So here, 2 times negative 8 is negative 16, minus 3y is equal to negative 16. The 16s are actually going to end up canceling each other out, giving me negative 3y is equal to 0, and I've got y is equal to 0. Check your work to see if everything works out. It does. And that is your warm-up for today.